Salutations, fellow chemists. So today we're going to look at combustion. It's my very first video, so I'm excited to do this as well. But what is combustion? Combustion is the reaction of an alkane with oxygen to give off heat and light. There are two types. First type is incomplete combustion. We'll do it this way around. And the second type, as you can guess, is complete combustion. So we go to this side, put complete. For all exam boards, you must know the definition of these two. So we'll start with incomplete combustion. For incomplete combustion, you don't have enough oxygen. So we say there is insufficient oxygen present. So I'm going to write the keyword insufficient. And this is all to do with oxygen. There is not enough oxygen around. Whereas with complete combustion, you've got more than enough. And in chemistry, that is excess. So you've got excess oxygen around. And then the last thing you need to be aware of is the products and the difference between the products there. So for incomplete combustion, you will be making soot and you'll make carbon monoxide. We're going to go and learn about why these are dangerous in a second. And then the last one is carbon dioxide, which is a gas, and H2O. You can put liquid or gas there because it's very hot, as I said before. And alkanes are perfect for this because they release lots and lots of energy, so they can be used as fuels. Sweet. So we're going to move on to balancing these equations here. What you need to be aware of is you've got the two types. When you look at incomplete combustion, you know you've got carbon and you've got carbon monoxide, but you also need to be aware of the fact that you make both carbon dioxide and water in those as well. But we're just going to focus on complete combustion. First thing you need to do, number one, is balance all your carbons in your alkane with the CO2. The second thing you need to do is balance your hydrogens with the water. And then the last thing you need to do is go back and have a look at the oxygen and balance those with the O2 that we've got there. So we're going to have a look at an example. I'm going to give you propane here with oxygen. And obviously that's going to make water and carbon dioxide, but I'll put carbon dioxide first, just for convention. So CO2 and water. I've left the state symbols out just to make it easier for us to write our balance in here. So remember, first step is to balance your carbons using the carbon dioxide. So if you have a look here, we've got carbon dioxide, we've got 3 carbons on here. So very easily you just pop 3 on that side. And then you look at your hydrogens, you can see you've got 2 hydrogens on that side, however, you've got 8 here. So you need a 4 here to make sure you've got 8 in total. And then 3 times the 2 there gives you 6 oxygens. 4 times that there gives you 4. So 4 plus the 6 gives you 10. Therefore, you must have 5 oxygens on that side. And that would perfectly balance this over here. Perfect. So let's have a look after we've had a look at the balancing of the equations as to how these can cause pollutants in the atmosphere. So I've got some of these pollutants here that you need to know for all of your exam boards. And we're going to very quickly talk about where they come from. And then we're going to move on to the environmental effects or the health effects of those as well. So CO is carbon monoxide. And we already know that comes from incomplete combustion, as we've seen already. So I'm just going to write incomplete COM just for space. Same with our soot as well. So C is just soot. So that also comes from incomplete combustion. And soot is just the black stuff that's left over when you have incomplete combustion, and that's basically carbon. And then here I have NOx. The X is there just to represent the fact that you have nitrogen oxide and nitrogen dioxide, and collectively we call those nitrogen oxides. So I put NOx there, and that is going to come from nitrogen reacting with oxygen in the atmosphere. So you've got lots of nitrogen in the atmosphere. When it's very hot, you can overcome the bonds in the nitrogen and react these to make nitrogen oxides. You also have some unburnt fuels that escape during the process of combustion. So these here are ones that just evaporate because it's very hot, and that is also going to be from incomplete combustion because not all of the fuel burns. And lastly, you get sulfur dioxide being made as well, because the sulfur will react with oxygen. So the sulfur will come from impurities in the fuel, and that will react with your oxygen to form your sulfur dioxide there. Sweet, so we're going to move on to look at the environmental or health effects associated with all of these pollutants, as we mentioned. The first one, so we have carbon monoxide. Carbon monoxide is very toxic. It's a gas, and the problem with carbon monoxide is it will bind to the hemoglobin in your red blood cells, and that's not great. The reason why that's not great is because it binds irreversibly and stops oxygen from actually binding to the hemoglobin. So it inhibits your respiration, and that basically could cause you to faint, feel very dizzy, and in some worst cases, you could actually fall into a coma, which is not ideal. So you need to be aware of that there. Next one, we're looking at the carbon, which is soot. For soot, you need to realize that soot can cause what we call global dimming. So let's write that down. And global dimming is not ideal because it screens the sun's rays from actually reaching the surface of the earth. And we know that we use the sun for lots of different processes. The plants need them for photosynthesis, for example. So it's not ideal if we're not getting as much of the sun's energy reaching the surface. Next here, these three are quite common because all of them will lead to respiratory problems. So I'm going to put that on this side. So we'll put respiratory problems. Excellent. But in each case, we can have a look at how they do that in more detail. So for your nitrogen oxides, they can form acid rain, and that's due to nitric acid forming when they react with water. When it comes to your unburnt fuels, obviously, it's not great to have fuels in the air as well. So those are mainly just for your respiratory problems. We'll keep that the same. And the last one there forms a very different acid, which also contributes to acid rain, but it's not nitric acid. Because you've got sulfur dioxide, you're actually going to form sulfuric acid. So that's the very last one here. So acid rain. And that's from sulfuric acid that you make there. So that is combustion of alkanes in a nutshell there for you. And we've also had a look at how to balance your complete combustion reactions, and also having a look at the pollutants that you form and how they are formed and the harmful effects they can cause as well. So make sure you like, make sure you subscribe and share my videos on YouTube. It's my first one, so I'm looking forward to making more for you guys.